We have installed a new instrument here at the center today, which is called simultaneous DSC-TGA, and model is SDT650. So instrument will be used to study thermal behavior of polymers or inorganic materials in a temperature range up to 1500 degrees C. The principle of operation is you have two independent channels measuring both simultaneously weight and temperature difference between sample and reference pan. There is a furnace which moves up and down, and it's all automated. Atmosphere within the furnace is controlled by mass flow controllers, where you can set up the flow of the gas via the software. Instrument has a touch screen for easy operation, which allows you to observe some signals of the instrument and also perform some operations, start and stop of the experiment, and things like moving the furnace like so. The instrument has been calibrated for you, so there is no need to calibrate before each run. And a principle of operation is quite simple. To start working with it, what you do, you wait until you are at room temperature. You need to open the furnace. Most of the time you will use ceramic pans to run your samples. So step number one, you load two empty ceramic pans. First one goes onto the reference arm, which is toward the back of the instrument. Sample arm closer to the operator. And you press STA. The instrument will close the furnace and measure weight of empty cups. You see status is stirring. Okay, so furnace is opening. It's ready to go. Status is idle. You then remove the cup. Put it aside. And now you can fill it in with your sample. Your sample could be something as simple as a piece of polymer, or you can run some inorganic material. And to do that, you just put a little bit of the material in a cup. Make sure it's spread through the bottom. and you load the cup back onto the arm. There is no need to weigh the sample because we're working with a very precise analytical balance. So your instrument is ready to be run. You can close the furnace, sorry. And now you can set up your experiment using this software. The software looks like so. This is your experimental page. So to create a new run, you click Create New Runs, sample name, calcium oxalate, pen type, alumina 90 microliters, which is ceramic in Australian language, operator. You will notice that sample name will appear in your data file name. So there is no need to change if you're okay with that. Then you can create your test. There are a few ways to do it. You can either choose custom created test, then you will get an editor to choose the segments which you want to use, or if it's just a simple test, you can use a template. So if you want to create a heating test, which we will do for this sample, calcium oxalate has 3 transitions. One losing water, another losing CO, and third one is CO2. So we heat this sample from room temperature up to 1000 degrees. In nitrogen atmosphere. Okay, so I'm ready to start the experiment. I hit start button. You will notice that it will go through pre-test, looking at stability of the balance. And when it says running, we move to results window, which will show you a real-time plot. So instrument is running. Status here shown is test. And eventually we will get something like that. I'm going to show you a typical file. Okay. So you can change your signals. Select variables. Y2. Sorry. Something like that. I mean, you have a lot of options here. So if you would like to analyze weight losses, you would go weight change, for example. Analyze. And so on and so forth. At the end of the run, your instrument will start cooling down. We use compressed air connected to the back of the instrument. It will kick in when furnace is around 600 degrees C and lower. If it's hotter than that, you can only hear the fan first, and then compressed air will turn on, and it will cool your sample automatically until the room temperature. So then you remove the cup, you clean it, you can perform next sample.